Hey guys, I finally picked up a 5Z3 rectifier for the Strymon Carlson 64 and a Philco 25A6 for my Philco 37611. Before I try using either of these, I want to test them. I got them off of eBay at a reasonable price. I've had pretty good luck taking chances with buying tubes off of eBay. But I definitely want to try them before I use them, even though they appear to be new old stock. And I thought this would be a good time to finally take a look at this Hickok 6000 I picked up off eBay a while ago. Looked to be in really good cosmetic condition, and I thought it would make a nice little upgrade from my Hickok 600. For those of you not familiar with the 6000, it is a dynamic mutual conductance tube tester, very similar to a number of other testers they made that uses an 83 rectifier and a 5Y3 rectifier. And this does actually do a true transconductance micro-mo test, where it measures the actual gain of the tube. Now, what's kind of interesting about the 6000 is this thing in the middle. They refer to this as an island, I believe, or at least that's what the radio guys call these on the forums. And they came in two styles, at least, maybe more. They can be removed and interchanged. You take out these two screws and you can pop this whole thing out and replace it. They have different tube sockets in them. This is the older style, which I understand is rarer. The newer style has compactrons and new Vistors and another type of newer tubes. And that's initially what I was hoping I got. I actually didn't pay attention. I saw this was an inexpensive price, looked to be in great cosmetic condition, it had a bin on it, and I just went for it. I didn't realize till I got it that I had the older style. And after thinking about it, really, probably 95+% of the tubes I test are this older style, so it does really make more sense. And I do have other testers for testing newer tubes. On the rare occasion I do need to test them, so that's nice. And one upgrade from the 600 is the shorts test. It does them all simultaneously. You don't have to rotate that switch through all the positions to check for shorts. There's a little hood here with some lights underneath it. Otherwise, very similar to the 600 and the 800 with its design. Same bias and shunt control. Although I think they call the shunt the English control on the 600. Anyways, I have not tried using this yet, and before I do, I want to take a look inside and check those two tubes. 83 tubes have gotten quite pricey, I think because of all the guys who want to keep their tube testers running in tip-top condition of grabbing up all the 83 new old stock tubes. But I do have one or two around if it does need to be replaced. One last thing before we take a look inside. There's a roll chart. It moves quite nicely. That covers quite a few tube types, but it did also include this stuck underneath the front, the top cover for the obsolete tube types. And I think it's kind of cute that they use this old Gothic font for obsolete tube types. So I imagine this has the 4 and 5 and 6 pin tubes. All the double digit. Yeah, it's got all the loctals too. Some of these aren't all that obsolete. Maybe obsolete by the time this tester came out, but like a 6 SN7, 6 SL7. Well, actually, the SN7 isn't in here, but the SL7 is, and the SQ7, SR7. I guess they consider the 6 SN7 still to be a relevant tube type, but not a lot of others. A lot of rectifier types. So I suspect both of the tubes I want to test are in here. Yeah, there's the 5Z3, and let's see, and there's the 25A6. Alright, so I've got 4 screws out, so I should take this out. Doesn't weigh that much, so it's fairly easy to get out. And what we see is pretty typical tube testers. A transformer with a whole bunch of taps for all the different filament voltages. There's those two tubes. Looks like the 83 is the original Hickok. And looks like that electrolytic across the meter's been replaced at some point, but it's still got this old paper type cap. I'll replace that. There's not a whole lot in these. Power resistors don't go all bad too often. Few carbon comps. I can check those, see if they're in spec. They have ceramic discs on these, the shorts test. Those are probably fine. And a few here on neon bulbs that limit the current, I think. Oh no, those are actually the transistor test sockets. So those actually test transistors, but it's only going to be germanium and a really early type C. You can tell from the sockets they used. Alright, so all I'm going to do is check these tubes because I hear something rattling that does not sound good. Oh yeah, nice chunk of glass in there. Looks like, yeah, one of the ears broke off on this base support structure there. Doesn't mean the tube's bad. And the base is a bit loose. So that's the 83 mercury rectifier, and this is a 5x3. It's a more modern RCA. Probably a replacement. Now, of course, I can't check these using this tester, so I need another tester to test the tubes in the tester. If you remove these two screws and wiggle a little bit, you can pop out the socket module. Kind of convenient if any sockets get worn out and you need to replace them. You can take this unit out and replace the sockets. For testing these two tubes, I will use the Hickok 600A, a little bit older, but internally a rather similar design. So let's see. This also has an obsolete tube setup chart in it. And there's 83, 75 on the filament voltage. JR03, JR03, put this guy in here. Now, mercury rectifiers should be left to sit for a while to warm up. So do my line adjust. So somebody asked me recently if you should do the line adjust before or after you put the tube in. Fine to do it before you put the tube in, but you should also do it again after, because the tube will load down the circuitry, especially for a power tube, which will drag down the line voltage, so you should readjust. In fact, you can see the fuse here is even dimly lit. Doesn't mean the tube is short, it just means it's drawing a lot of current. There's at least a 2, if not a 3 amp filament on that. So this isn't really a fuse per se, like that would burn out. It's kind of a light bulb in series with things. So this is light really bright if there is a short. See that mercury is vaporizing inside there. That's why you need to let these sit for a while before you test them. And when you do, if they're working right, you get a nice blue glue inside. And for these, 0 and 62. And notice on this older type tester for the shorts, you have to rotate this through 6 positions. So, do it first. And then I press P3. And that's really weak. Glow, but really, really faint. Definitely deep into the replace. Suspect though this might still work okay in some applications, maybe even that tube tester. Those rectifiers, using these tube testers, there's not much current flowing through them. So even if it's really weak, it might still be usable. Let's try the other side. And the other side's actually good. Yeah, you can see much stronger glow on that side. Here's a closer look at what I'm talking about. So there's two filaments. There's a blue glow. And on the other side, that's the weak side. Well, since I happen to have an 83 that I know is good, I'm going to go ahead and use that because I want my tube tester to be reliable. Got it right here. Pick this up from Find a Tube. Find a tube vendor online. Sells both new and used tubes. I tried to get a new old stock, but he just didn't have any. So this is a used, tested, good 83. And I'm going to retest it myself. Tongue sole. It's being in really nice condition. Maybe I'm wrong. You know what? No. Yeah, I am wrong. I think about it. I wanted to get a used. He didn't have any used, so I got a new old stock. That's what it was. That's what I like about Find a Tube, is he sells both new and used. Used when he's got them in stock. So for some expensive tube types, like a 45 or something, if it's radio you don't use that often, you just want an expensive tube to get it going, you can buy used tubes from him at a reasonable price. See, as it warms up, the mercury inside starts vaporizing, coating the inside of the tube. As far as how long to let them sit, well, I kind of like to do it until you can actually feel the warmth on the top of the tube. Okay, it's nice and warm. This has a getter on top, so you can't actually see the blue glow very easily, but you can certainly test it. So there's one side, and we can see it. And very strong emissions, as I expected from a new tube. And let's check the other side. Alright, so got a very good 83. Now let's check the 5Y3. Okay, 5Y3 is warmed up. No shots. Excellent emissions on one plate. Let's try the other. Alright, got a good 5Y3. I replaced that electrolytic on the meter. This pot here is actually part of the meter. It's factory calibrated. You can see they put a little bit of sealant on there, but there is a way to double check that. We'll get to later. Here's a schematic I found online and printed out. The resistor values are pretty tiny, so I went in and wrote them in by hand larger so I could read it. And now I'm checking the resistors. Also found a good online calibration and refurbishing guide. And one of the directions was to make sure you spray all the controls with deoxit. And also, good tip to remove this paper roll. They didn't say why, but I assume it's because when you spray these switches with deoxit, very good chance you're going to get some of that on this paper roll, which would smear the printing on it. So I'm going to go ahead and take this off. Because it is just a screw on either side. You take off from the front and this roll just comes out. I cleaned all the controls with some deoxit. All the resistors tested within spec, so I flipped the control panel back down, plugged it in, and I'm going to try powering this up for the first time. I also read the owner's manual to see how this works, because it's a little bit different than my other tube testers in that when you turn it on, you should automatically be in line test mode, and the needle should swing over without having to push anything. I give some indications here. I guess those are rough estimates of where you should put this given your line voltage. Well, I've got around 125, so let's see what happens. Not much of a click, but I guess that's on, and the meter indeed has moved And let's see, get this up to the line test. A little off from the 125, but hey. Important thing is that the needle's on line test, and all the shorts lights lit up. Now that's something that threw me at first, is that a light means good. When you put a tube in, if one of these goes out, it means you have a short. Now I went ahead and set this up for a type 6J6, because I happen to have some lying around. Now this is a used one. I pulled out, oops, so it's a 6AG5. Here. This came out of an RF generator. And it was an RCA, and I think this might be very well be the original tube, so I bet it's seen a lot of use. I have not tested it yet on anything though, but I'm hoping that it's going to test a bit weak, and then I can compare this to my 600. Now, I don't expect tube testers to ever agree 100%. That's just not going to happen. And I will go through and calibrate this independently. But at least I want to get a ballpark idea if it's working right. So, none of the shorts lights went out. Well, another thing that's kind of odd, I think, about this is the filament continuity test now. Most tubes you can see the filament glow, so I know I have continuity, but you can also push this button. And if the needle stays around the line test area, it's good. If it was open, I think it just drops down to 0. So we can just go ahead and test it. And creeping up into the good. Okay, now I can compare that to, this is a new old stock 6J6. So I had the line adjust, and it crept up a little. Oh yeah, of course. Yeah, you adjust the line adjust when you put a tube in, because that loads things down, so it's going to drop a little. So tweak this back up to get it on the line test one. There we go. There's shorts in this, as I would expect. Continuity again, and test. Ah, good. It seems to be a reasonable indicator that this is at least partially functioning correctly. Here's the calibration guide I've been going to at tubesound.com. I simply Googled for Hickok 6008 calibration and came up with this website. Also have a lot of service hints and interesting notes and history along with this tube tester. So what I want to do next is the shorts test. And they mention how it works and how you can do a simple test with cathode and suppressor switches in the same position. Example 1133, through the range of positions, the short indicator lamp should show a short. So those lights should go off as I go through those various positions. Earlier I'd also mentioned about that panel meter. Well, here is how you can check its functionality. So in other words, when the meter is half scale, if you take a multimeter and put it across it, you should get about 58.25 millivolts. Okay, flip the tester back around and have it powered up. So here's the shorts lights. Remember, when the light is illuminated, it means there is not a short. So a simple test of functionality is with cathode and suppressor. When you put them in positions like 1, 1, 2, 2, 3, 3, you should show a suppressor to cathode short, except for position 0, 0 that I have them in right now. So let's see if we go 1, 1. Sure enough, light goes out. 2, 2, 3, 3. 4, 4, and so on all the way around. Cool. The shorts light and meter functionality seems to be correct, so now I'm proceeding with the line calibration. To do that, you set this up as if you were testing a 6L6. except you leave the bias and shunt at 0. I got all those switches, otherwise set up for a 6L6. And then you want to monitor the voltages in pins 5 and 8. I've got one of these octal test adapters, which makes that a bit easier. Shoved a bit of bus wire into those 2 pins and clipped my meter in there. So the idea is when you press test, you should get 2.5. And I have just about that. And you're supposed to tweak this until you get 2.5 exactly. And when you let go, this should be right on line test. And mine is off just a hair. And you can tweak that by with the internal pot below. It's got a blue handle on it. Yeah, I know where that is. It's right on the board next to that 83 tube right there. And the problem is when you put this on its side while you're doing this, gravity does affect the needle pointer a little bit. Yeah, so right now it's showing quite a bit off to the right of line test, but when I put it like this, the needle's pretty much right on line test. So a little tricky. You want to do this while you've got the thing horizontal and get under there and tweak that. So I've been trying to prop this up on some blocks here so I can get under there and make adjustments while I've got this upright. I chipped away at the glue on here and tweaked this pot so that it's dead on line test when I get 2.5 volts AC. Now I'm checking the plate voltage, which is supposed to be 150 volts, plus minus 3 volts, when tested with a VOM, which would have a resistance on it much lower than a digital multimeter, but you can simulate that by throwing a 250K resistor shunted across those 2 pins. And when I do that and press test, I get 154, 153.9, which is pretty darn close. So I think we're okay there. That's entirely dependent on the earlier calibration and the health of your 83 tube. And I know I got a new old stock 83 and I went through and calibrated that. In the documentation here it says that if you're within 150 to 153 or 150 to 155, you're alright. Now I'm going to check the grid bias voltage, which is between pins 5 and 8. This time we're going to use a 50K shunt resistor. And we should get minus 40 volts, plus minus 2. That should look right. Hardly getting anything. Oh, with the bias control at 100, I still have it at 0. Let's check that again. Alright, minus 40.3, well within spec. And the final test I'm going to be performing is the bridge balance test. You put a 10K 10 watt or better resistor between pins 3 and 8, set the shunt to 3000 and press test, and the needle should be within about 1 tick of 0 ideally. And yeah, about 1 tick above 0. Then it should be able to position the shunt at various positions nearby, and it should stay reasonably close to 0. I think you can just keep the button held down while you do it. And that concludes the calibration, so now I can get back to testing the tubes. So first up here is the Hickok 25A6. I've already got the controls set up for it. Let's pop it in. And right away we notice that the needle sags a bit. That's because of the current draw from this tube, so we have to tweak the line adjust to get that back up to line test. Right about there. Let the tube warm up. Make sure all the shorts lights stay illuminated. I can already see the filament glowing, but we'll check filament continuity anyways. That's good. Remember, it should stay around the line test mark when you do the filament continuity. Then we do gas test. It's good. And now we can do the transconductance test. Alright, got a nice strong tube. Cool. Now, let's move on to what should be a new old stock 5Z3. So change this to 5. Okay. Again, we get the meter sag as this tube draws a lot of current. Get that turned up. Again, we can do the filament continuity and gas, and then do the test. Yeah, it's a good strong tube. Cool. And finally, I pulled the 71A out of one of my working radios, and I know it's good. Got all the controls set up for it already. No shorts. Got the line adjust set, and here's the test. Alright, so that is going to be it. I hope you enjoyed this look at restoring and calibrating a Hickok 6000A tube tester, and I am going to be listing this for sale on eBay, so happy bidding.